Good morning, ladies and gentlemen. We are looking in this video at the question 6 of November 2016 question paper. This is a functions question, nice grade 12 question with inverse and all that. We are given here fx, which is minus x plus 3 straight line equation, and gx, which is log base 2x. Gx, which is given as a function, is actually one of our inverse functions. Hopefully you know by now that the log is the inverse function of an exponential. So if I get the inverse of this function, I'm going to end up back with the original exponential function. Normally, my function is exponential and the inverse is log, but they've swapped it in this case. So the function is now log, and then obviously its inverse will be exponential. 6.1, on the same set of axes, sketch the graphs of f and g, clearly showing all intercepts with the axis. Okay, so I'm going to start with that. To sketch the graph of fx minus x plus 3 straight line equation, I need the x-intercept and the y-intercept. So the x-intercept I get by making y 0, so minus x plus 3 is 0, then minus x is minus 3 or x is 3, so there's my x-intercept. And I also need the y-intercept, which I get by making x 0, and that produces then y is 3. Okay, so that's not very difficult. On the same set of axes, I'm just gonna quickly draw a set of axes here. The x value is 3 and roughly the same distance, then obviously the y value is 3. So there is my graph of f, right? And then I also need to sketch the graph of g, which is log base 2x. Right, now there's two things you can do here to sketch the graph. The one thing you can do is you can first work out the inverse and then think of the inverse graph, which is an exponential graph, and then reflect it to draw your log graph. I know that this graph here is going to look like my exponential graph is there, reflecting it in the line y is equal to x. This log graph looks like an exponential graph, but it's formed here. So obviously I'm not going to have negative x values that I can substitute in there, but I can substitute 1, 2, 3 for x and then just get some points to plot, and I'm going to have a asymptote on the y-axis, and then the graph should lie there. So, well, you can do that, or you can revert back if you're more comfortable sketching the exponential. I'm going to do it both ways just so you can see. So to straight up just sketch the I don't actually need 3 lines, sorry. To straight up just sketch the log graph, what I can do is just get values, but I'm not going to substitute minus 1, 0, 1, because I know that the graph is going to lie roughly there, like an exponential graph, but like that's my asymptote, okay? So it doesn't help me to substitute minus 1, 0 there. If you didn't know that and you start out there with log base 2 and I make that minus 1, it gives me an error. Then I make it 0, it gives me an error. It doesn't help me. So I'm going to just plot 1, 2, 3. Let's rather do that. So 1 is 0, 2 is 1, and 3 is 1,58. Yeah, 1,58. So at 1 I have the point 0. At 2 I have the point 1, which is going to be roughly there. 1, 2, 3. And at 3 I have the point, there's now 1, 2, which is 1,5, something there. So I can see that this graph is going to go there. I actually only need the x-intercept. These 2 points just basically assist me to make sure that I'm making the graph away from the from the asymptote in the right direction. So if I had the points, if I had these points and I plot them and I see they go this way, then I can see this graph is going to maybe look like that. And since the points now go this way, I can see this exponential graph is going that way. So that just sort of helps me with the shape of the graph a little bit. But the only crucial thing that you must have here is that one there. So that's the one method you can use. The other method you can use is, let's quickly find the inverse of g, because I think most of you are more comfortable sketching exponentials, right? So to do that, I'm going to swap the x and the y. So in this function, I have y is equal to log 2x. To get the inverse, I'm going to make it x is equal to log 2y, right? X is equal to log base 2y, and hopefully you know your log definition, that the base is to the power of the answer, so 2 to the power of x is then going to be y. If I change this from log form to exponential form, 2 to the power of x is equal to y, and then I'm going to sketch y is equal to 2 to the power of x, right? Which means, let me just do this in pencil because this is not part of the actual sketch, right? So I can do it in pencil and maybe just take it out. Normally, to sketch an exponential graph, what you do is you're going to make the x -1, 0, and 1. So if x is -1, this is 2 to the power of -1, which is a half. 0 is 2 to the power of 0, which is 1, and 2 to the power of 1 is going to be 2. And then I have the points at -1. Let me just try and make that distance more or less the same. At -1, I have a half. At 0, I have 1, and at 1, I have 2, right? So I can see the exponential graph looks like this, right? My typical exponential graph, which is the inverse of this log function here. And then I know that inverse functions are a reflection on the line y is equal to x. So if I sketch this in pencil here, this is going to assist me to get this graph. So if the point 1, 2 lies on this graph, the inverse of it, which is the log graph, will have the point 2, 1. Swap the x and y. Will have the point 2, 1, 1, 0, and if I swap this, a half at x is a half, I will have the point y is -1. So you will have those 3 points instead of this. But then you see the point 1, 2 will be the point 2, 1 on your inverse. So then you can just swap the x and y's and plot those points. So the point 0, 1 is going to be the point 1, 0 on your inverse, and the point -1, a half is going to be the point a half, -1 on your inverse. So you can just roughly make a rough sketch of the function of the exponential and then reflect all of the points to sketch this function, and then you can take that out, or I mean leave it there because they might ask you to sketch it later on. Just check for that before you maybe take this off. Okay, so on the same set of axes, F and G, this is my F, and this one here is my G. Okay, then 6.2 is write down the equation of G inverse, G -1x, the inverse, in the form y is equal to x. I already found this here, so G minus 1x is going to be 2 to the power of x. Just since we are in lockdown and some of you might have missed this in class, you have a definition that log base a to the log base ax is equal to y. This is the definition of a log, means the same as a to the power of y is equal to x, right? A to the power of, you see that base a is with the x in the log, and then the answer alone is y. So they will basically swap places. You see ax y, now it's ayx without the logs. So if you just swap those two and take the log away, right, this is the definition of a log. Okay, this translates to that, and I can use logs to find exponential, solve exponential equation. Okay, so this is the definition. So that's what I did here. You see the 2 was with the y, so I swapped the x and the y so that the 2 is with x and the y alone without the log, right? Okay, so that's log there, 6.2. 6.3, explain how you will use question 6.1 and or 6.2 to solve the equation log 2 3 minus x is equal to x. So if you see, well, this is the equation of g with the same base 2, but now the x has been made 3 minus x, and the y is equal to x. Okay, so in the equation, what they've done is they've replaced it with the point x, which is 3 minus x, y, which is x. Solve that equation. Y is equal to x. Is this line, and 3 minus x is this line. So basically, this is 3 minus x is this line equation, right? And x is this line equation. Y is equal to x. So what they've done is they have substituted this point of intersection, 3 minus x into this equation, which, unless that lies on there, I'm not sure if that's going to help me. I think it might be easier to just go to the exponential form, because that doesn't make sense a lot. If I go to the exponential form, then obviously the log 2 3 minus x is equal to x translates to 2 to the power of x is 3 minus x, which 2 to the power of x is the graph of the inverse, and 3 minus x is this line here. This line here. So obviously it's that point of intersection. It's, you see that 2 to the power of x is this, is the function g minus 1x. So g minus 1x is equal to, and 3 minus x is this line, minus x plus 3. If I just take the x, if I swap these two terms, it's 3 minus x is the fx. So to solve this, well, this translates to g minus 1x is fx. So to solve, I can write down the point of intersection between g minus 1 and f. Right, so if you can just look at the graph there, that point where these two cuts which is, if you draw this to scale, mine is not really drawn to scale, but it seems like roughly a half, where x is a half 2 maybe, or 1, 2. 1, 2 lies on this graph. Will 1, 2 lie on the other graph? Actually, yes. So the point 1, 2. Actually, the point 1, 2. Okay, mine is not even on scale, and you see the point 1, 2 lies on this graph of g minus 1. It's a point that I sketched there, the point 1, 2. And if you test 1, 2 in there, substitute 1 in there, it actually produces 2. So the point 1, 2 lies on both these graphs, so it is the point of intersection actually. That's just a lucky shot that it's there, but then you can just read it off. They don't actually ask you to answer this, they just ask you explain how. And if I rewrite this in exponential form, I see, oh, this part here is g minus 1 and this part here is f. So to solve that equation, what I can do is I can just write down the point of intersection if I can see it on the sketch. If the better my graph is drawn to scale, the more accurate I will actually get the point of intersection between this graph and that graph. But luckily or accidentally I have it there as 1, 2. Okay, then question 6.4 says then, oh, write down the solution. Okay, so the solution is 1, 2. Okay, so that is the solution. I actually have it there. Okay, that's question 6. I'll see you in the next video. Then we're going to also look at the functions questions from November 2017.